The alert came in as a cascade, error rate above 30%. Then another, checkout failures increasing. Slack exploded, payments failing, users stuck at checkout. Slack exploded with questions. Why are orders duplicating? I opened Grafana, traffic was normal, latency was rising, error rate climbing fast. But the strangest part, some requests were succeeding. Others were failing in unpredictable ways. Same endpoint, same inputs, different outcomes. That's when I knew this wasn't infrastructure, this was logic. We were running on AWS, EKS cluster in US East 1, around 90 microservices. Traffic averaged about 4K requests per second. Peaks could reach 10K. Front-end went through CloudFront and an API gateway. Back-end services handled orders, payments, inventory. Databases included RDS, PostgreSQL, and DynamoDB. Redis was used for caching and session state. Feature flags were managed through a centralized service. Flags were evaluated at runtime. Used to gradually roll out features. CI/CD was GitHub Actions and Argo CD. Monitoring stack included Prometheus, Grafana, and distributed tracing. Feature flags were supposed to reduce risk, allow controlled rollouts, not cause incidents. Users reported inconsistent behavior. Some could complete checkout, others got errors. Some orders were duplicated, others disappeared. From the system perspective, services were up. No crashes, no resource exhaustion, but error rates were high and patterns were inconsistent, which made it harder, because nothing was clearly broken. First thought was deployment issue, maybe a bad release. We checked recent deployments, nothing significant. Next thought was database inconsistency. We checked transactions, some anomalies, but not enough to explain everything. Then we looked at request traces, that's where it got interesting. 2 identical requests, different execution paths. One called the new payment service, the other called the old one. Now we checked feature flags. There was a new flag, use new payment flow. It was supposed to be enabled for 10% of users. Gradual rollout, that was expected, but then we looked deeper. The flag evaluation was happening in multiple services, not centrally. Each service fetched the flag independently and cached it locally, with different refresh intervals, which meant at any given moment, different services had different flag states for the same user. Now Slack was getting tense. Why are we mixing payment flows? Some services think flag is on, others think it's off. This is causing inconsistent state. We traced a single checkout. Front-end saw flag as enabled. Sent request down the new path. Order service saw flag as disabled. Processed it using old logic. Payment service saw flag as enabled. Used new API. Now we had a mismatch. Different parts of the system executing different versions of the same flow. The root issue was inconsistent feature flag evaluation. Feature flags were not treated as a single source of truth per request. Each service evaluated the flag independently. This created a split-brain scenario. The system behaved unpredictably, not because of failure, but because of inconsistency. First step was to disable the flag globally. Forced all services to use the old payment flow. That immediately stabilized behavior. Error rates dropped. Then we flushed local caches. Next, we implemented request-scoped flag evaluation. Front-end evaluated the flag once, passed it through headers. All downstream services use that value. No independent evaluation, no divergence. We also reduced cache TTL for flags. System stabilized fully within about 25 minutes. What failed was not the feature flag. It was how we propagated it. We assumed eventual consistency was fine. Detection was delayed. We saw errors, but not the divergence. Tracing helped, but we weren't correlating flag states. Lessons. Feature flags must be consistent within a request. Critical paths require deterministic behavior. Catching must be carefully designed for configuration data. Observability should include feature flag state. Rollout mechanisms can introduce risk if not aligned with system architecture. In the end, the system did exactly what we told it to do, just not what we expected.